Welcome to the Contractor School. Remember to take good notes. On this section is on motors and generators. Not too many generator questions, but definitely a ton of motor questions upcoming for the calculations portions of your exams. Okay, so let's go and turn in our code books right away. Let's get on this thing right quick. 43022, 43022 is a standard for single motors and a standard in general for motors. 125% multiplier. We've talked about that before. That's where you find it. 43022, and it's all over the code book. Actually, that's probably the best place to highlight it. And you could just highlight the paragraph, kind of like I did, put a box around it, circle 125%. So that's where that comes from. We won't go back there again. That is a standard. It's a rule of thumb that we must know. Okay, so moving on from the code reference, there's some tables that we'll need as well. And in this particular case, we need to size using the tables. But this one here, it already gives you the FLC 62.5 amps. So we'll go ahead and use that, right? But in general, it's going to give you horsepower. Then you got to go to the tables. This one gives you the FLC. So let's read it. What would be the minimum size 75 degrees C conductors? And notice it says 75 degrees C. Remember to default there anyway for motors. Okay, very important issue there. For a motor starter's secondary circuit, given that the secondary FLC is 62.5 amperes and the starter overload is 80 amps, well, don't get messed up with this. This is fluff. This is there to just kind of like confuse you. If you size on 80, it's going to mess you up, right? We're talking about the secondary side, and the FLC is given. So, I mean, come on. There's the nameplate rating right there. You always default to the nameplate rating. And if the nameplate rating isn't given to size the branch circuit conductors or feeders, then you use the tables. Okay. So let's go ahead and look this up now. Well, actually, that's just simple math, right? Just simple math. Let's go ahead and put this in our notes so that we make sure that we get it. Okay. Open a notepad. If you got to start a new page, that's fine. But if the motor, by the way, we should write down that article reference, the 430 22, that gives us our 125% rate. Make sure you write that down, because you're gonna say, well, where do we find this at? So make sure we get this in our notes. The motor FLC, right, rating is 62 amps, right? 62.5 amps, right? Well, if we get that, we multiply by 1.25, right? According to the code reference here, right? If we multiply by 1.25, very simply, right? Use our calculator here. That slows me down anyway, right? 62.5, and we multiply times 1.25. I get the 78, right? So if I pull out my calculation, pull out yours, make sure you got it right, make sure there's no issue on the math, okay? So once again, 78 amps, pretty easy. Now, we've already been to this table several times, right? So we're not going to go there again. Well, no, let's go ahead and go there again, because in this case it said use the 75 degrees C column or terminations, right? So since that's the case, right, we size our conductors on what table? Where do we size wire, right? And passes of conductors, right? Table 31015, right? 31015. If you couldn't answer that question, boy, you've been absent, right? We got to be able to know that one. That's where we size wire. I mean, that's that's a standard. That's called fundamentals here. We've got to be able to do that. So let's just go ahead and turn there real quick. I'll turn there. You're probably already there. If you have a code book that's tabbed, which you should, then you're probably already there. It takes a little longer using the software. Okay, so we use 75 degrees C. We slide down till we see 78 amps. I don't see 78, so we're stuck. Well, come on now, guys. We don't get stuck, right? We know what we're doing, right? We go down to 85, and that corresponds to a 4 AUG. And we just finished a very easy question, right? So let's put here in our notes, size up to number 4 og, right? And that is the correct answer in that case. Okay, so pretty easy question. They're going to get a little bit trickier, so let's just move on, right? What would be the correct minimum size of the equipment grounding conductor for a circuit protector with dual element fuses? Okay, this one's a little trickier because we're not really sizing the wire, the conductors to the motor. We're sizing the equipment grounding conductor for the motor, okay? So little different. This is kind of a curveball. Look how many steps we have here. Let's not mess this one up. Let's do it right, okay? So in this case, if we know that it's a 2 horsepower motor, single phase, the first thing we need to do is look up the FLC, okay? So let's go ahead and put this one in our notes. We need to look up the FLC. So where do we do that at? I'm actually gonna probably need to start a new page, so a little bit longer. Well, I guess we could fit it there. If we, step number 1 here, right, is to get the FLC, right? And we get that from table 430 248. Why? Because that's our single phase table. Okay, so that's the first thing we need to do. So let's do that together, right? Let's go ahead and go to this table 430 248, and it should say 24 amps, right? Kind of cheated there, right? I looked on the notes of the question, but let's verify. Let's make sure we got it right. So when we get there, let's go ahead and highlight the top of the table. Make sure you put a box around. That's what I would do. And then with your pen, circle single phase, right? Circle single phase with your pen. Additionally, to the right of it, you see a 2-phase motor table. I'd put an X through this. I'd scratch this one. I'd scratch this one out because we need this one over here on the left. Put an X through the other one so you don't accidentally use that one. And then if we flip the page, we got the 3-phase table, right? We got the 3-phase table. Circle the 3-phase right here, right? Circle that 3-phase right there, and then box all the way around the table, okay? So those are the 2 tables we're going to use back and forth, back and forth, back and forth on this section in this lecture, okay? This one happened to be single phase, right? It was a single phase question. So single phase is up here. 200 I'm sorry, not 200 volt, not 208 230. That those are kind of weird numbers, okay? 208 single phase and 200 single phase, but this one very typically is on the exam 120. So I'd highlight that if I was you. And then in this case it was 2 horse, right? So wouldn't we just line up that row with 2 horse and we'll see the 24 amps, okay? 24 amps FLC, full load current rating of the motor. So that's what we need to write down there, is write down our, from the table, 24 amps. Now, the next thing is we need to read carefully because the question said it's using dual element fuses. If it's using dual element fuses, there's a table for that, right? There's a table for that, and we got to make sure we use the right table, okay? So and the reason we need the overcurrent protection is that our equipment grounds are sized by the overcurrent protection, right? They're sized by the overcurrent protection. So let's go ahead and do that. Let's go ahead and go to the proper table 43052, right? And let's knock this thing out because this table is, I think people just miss it. They don't know where it's at. Don't have it tabbed, whatever the case might be. But this is for overcurrent protection, okay? Overcurrent protection. Table 43052 for branch circuit, short circuit, and ground fault protector devices, right? That's overcurrent, right? And it's based on the percentages of FLC. The FLC we already have, right? We know that's 24 amps. And the question is it a non-time delay fuse, a dual element fuse? In this case, it is, right? Dual element. But they could ask you instantaneous trip breaker. They do. 800% is a big multiplier. Or inverse time circuit breaker. Now, there was no indication what type of motor, so just default the squirrel cage if it's not known. So take a note on that, or just swipe this whole column, I'm sorry, this whole row here for squirrel cage, because that's typically your numbers. Typically your multipliers are 300%, 175%, 800%, or 250%. So swipe that scroll cage, and if you have default here, okay? Now in this case, it's single phase motors, right? So since it's single phase motors, we'd be up in here, and it's a dual element fuse, so we'd be here, and you can see the multiplier 175%, right? 175%. So not too tough, right? Not too tough. Let's just write that down in our notes here. If we go ahead and write that down in our notes, get out our notepad, we need a multiplier. Let's write that down. Step number 2, right, is get our multiplier, right, from table 430.52, right? And I found 175%. We all saw that, right? So when we multiply here by 1.75, sure. Simple math, right? Simple basic math here. Multiply this thing out. Let's make sure we do this thing correctly here. 24 amps times 1.75, and we get the correct answer. Well, not answer, right, but it's part of our step, part of our procedure here, right, is 42. Was it exactly 42? Let's see here. Yeah, it was 42 amps. Okay, 42 amps. So that's the beginning, right? We need that. Okay, but that's not a standard overcurrent protected device, right? That's not a standard size. So wouldn't we need to take this on over? Let's draw an arrow this way, right? To table 240.6, and we went there in other lectures, right? And I think we would all agree, right? Pretty easy to find this thing. Let's just go there real quick. Not hard to do. 240.6. It's a table nowadays. And well, 42 isn't there, so I'm stuck. No. We size up, right? We size up to 45, right? So in our notes, let's go ahead and put that 45, right? 45 amps for the fuse, right? In this case, dual element fuses, right? For the fuse. So let's just put that in there, right? Well, if our overcurrent protected device or overcurrent protected device or fuse is 45 amps, right? That is the value that we need to take over to the table to size the equipment grounding conductor. So now this is kind of like a procedure here, right? Now we're going to need to go to another table 250.122 to size the wire, okay? And then we knock this thing out. That's pretty good. So let's go ahead and go size the wire there in this equipment ground table 250.122, and very simple table. We'll come to it, I'm sure, in other lectures here, but very simple table to use. The by the way, aluminum's almost never used. Scratch it over here. This aluminum side's almost never used, but copper is, so highlight this copper column. That's important. Or go around it with a little box or something. And this is asked, I'm telling you, at least 10 times on the exam in various tests, various questions. And a copper equipment grounding conductor is based on what? Well, it says right there, overcurrent device, right? Overcurrent device. That's why we needed the overcurrent device size, right? So we needed to get the FLC, right? Let's go back here and check this out. We needed to get the FLC right here, right there, right? And then we needed to get our multiplier by the table for overcurrent protected devices, get our math done here to 42 amps, and then size up to 45 as a standard overcurrent protected device because we needed it for this table, right? Overcurrent device, right? 45. And you say, well, 45 ain't there, so I'm stuck. No. 45 falls in right in here, doesn't it? So when we size up to 60 amperes for the fuse, in this case, dual element fuse, and slide over to a number 10, right? Slide over to a number 10. So let's go ahead and put that in our notes, and we just knock this thing out, right? In our notes, we size up. Put in your notes here, size up to 60 amps, and it lists a number 10 og, and we just finished that question very well. Okay, 10 og, and put a star on it, right, in case that shows up on the examination. That's the answer. Okay, so there's just a ton of questions they can ask on motors. There's just so many to choose from. It's very important that we don't get stuck on these. They're kind of time consuming, but we can definitely do them, right? In this case, we were sizing over the equipment grounding conductor, but we started with a motor issue, right? So let's go ahead and go on to another question here on motors. A single motor. Eventually, we want to go to multiple motors, but this one is a pretty good question, right? And notice that it gives you. Notice this question gives you the horsepower, right? Of this, it's a single motor, right? But it's 2.8, 3-phase, 5 horse. But then there's a nameplate. Well, hold on now. Why do we have the horsepower and the nameplate given? Well, be careful now. Do we use the horsepower or do we use the nameplate? Well, when we're sizing the overcurrent protection, we want to use the nameplate, okay? When we're sizing the branch circuit conductors or feeders, we want to use the tables. Now there's a place where it says that, and a matter of fact, I got it typed right here. Rule number 1, when sizing the feeders or branch circuit conductors, the conductors use the tables. Very important, right? And so I want you to write that in your notes. And rule number 2, when sizing overcurrent protection, use the nameplate rating, not the tables. Very, very, very important issue. I'll give you a second to maybe take a short note on that. Matter of fact, let me just put it in my notes simply, and then you can put it in your notes so that it makes sense to you. But this has got to make sense, folks. This has got to make good sense here. I need a new page here. So when you're sizing, talking about motors here, of course, talking about motors. When sizing the branch or feeders, right? These are conductors, right? When sizing the conductors, we want to use the tables, right? Namely 430, 248, and 250, right? One of them is single phase, the other one is 3-phase. Very, very important summary. Wake up here if you're dozed off here. This is very, very important because you're going to miss some questions if you don't pay attention to this section. Okay, now to size the overcurrent protection, right, use the nameplate, right? So for the conductors, use the tables. For the overcurrent protection, use the nameplate. You've got to remember that one or you're going to miss some questions big time. Okay, so in this question, let's go back to the question now and be careful now. Since the question is asking for, and by the way, we can highlight it a little bit later. Let me just tell you where it's at. It's going to be your job to go find it. 430.6. Let's put that in our notes. All this is 430.6. It's kind of wordy in there, okay? But that's your article reference that'll tell you that. Read it, highlight it, make sure you understand it. It's a couple of paragraphs worth. That's a very good summary there. Read it for yourself. Make sure you got it, okay? That's 430.6, okay? Now that we can move on here to the question, let's make sure we work this thing. So since it's asking for branch circuit conductors, and we have our summary right in front of us, right? If it's asking for branch circuit conductors, wouldn't we use the tables and the horsepower? Well, sure, right? We in this case we need this one, right? So I'm going to put this in highlight, and I'm going to put this one, in red or something here. We don't want that one. We don't want the nameplate rating. We want the horsepower. Why? Because we're talking about the branch circuit conductors. I hope that's making sense now, right? We don't need the nameplate. We don't want the nameplate. If we use it, we get it wrong. Okay, so let's go solve this thing and be done with it. Okay, and there's a couple of other issues here, right? It's a design B, 5-minute rated, short time. Uh-oh, there's another table needed there. But let's do one thing at a time. Okay, first of all, let's go get the FLC, right? We need to get that from the tables, right? So let's go to the tables. That's a 430, and this was 3-phase, right? So since it's 430, since it's 3-phase, we go 430.250, okay? And let's go ahead and go there. And simple table, right? I mean, it's a big table, but simple. And in this case, the particular motor was 208 volt, right? So let's write that in our notes, by the way. Let's write some of these details in our notes so we make sure we get it right. So it was a 208 volt 3-phase, right? And it was a 5 horsepower, right? And the nameplate, which we don't use, right, was 15.9 amps, even though we don't use it, right? And the other detail that is important is that it's 5-minute rated, short time, right? The rating is 5-minute short time. That's the duty, right? That's the duty cycle, right? 5-minute rated, short time. Okay, so those are the particulars, right? Those we need all that stuff, right? So in our table here, we need to go down, in this case, the 208 column, right, which is right here. And when we just line it up very simply with the 5 horsepower, so it's right there, right? Okay, so 208 and the 5 horsepower line up together right there, and I see 16.7. Y'all should see that, 16.7. We should be getting pretty good at these tables now, right? So that's the first thing we need to do. Step number 1 is the FLC, right? From the table, 430.250. We got 16.7 amps. Okay, now the next step after the 16.7 is to remember, right? Don't forget to multiply by 125%, right? So according to 430.22, right, we got to multiply by 125%, right? We've talked about that a bunch of times now, okay? And we need to knock that out. We need to multiply that, right? We need to multiply that, finish that one up, and get our calculator out. 16.7 times 1.25, and I get 20.875. 20, I'm going to put it over here, 20.875. I see, save some space on this screen here. Now, that is the FLC times 125%. But remember that it has a duty cycle, right? There's a duty cycle. So there must be a table in there somewhere for duty cycle. And let's see if we could find that thing. We're close, right? We just need to probably back up a little bit here and find that table. Let's see who gets there first, right? It's a race. Where did it go? Where did it go? The table's in here somewhere. I apologize. There's 52. We already were there. And lo and behold, where did it go? Okay, so keep looking for it. I apologize. Sometimes these tables are a little tricky to find where they're at. I'm looking all over the place here. There is a place for duty cycle. I wonder if I could just look up duty. Maybe find it. No. Okay, finally. So really, this is gonna have to be tabbed, or it's gonna be tough to find. I doubt you have a tab on this. Sometimes your tabs come with blank tabs, and you could tab that and then use a Sharpie on your tab, and that would be acceptable as long as it's permanent. Permanent tab, permanent Sharpie. Okay, so 5-minute rated right here, and then it was short time duty, right? So isn't our multiplier right there? Sure. Short time duty, 5-minute rated, 110%. That's the number we were looking for. Okay, so back to our code book. To our notepad. Once again, that's table 430, 22E. So let's put that in our notes. Table 430, 22E. Right, and that gave us 110%. Right. So when we get our 20.875 amps times 1.1, right? And then we get the correct ampacity, right? So let's go ahead and pull out our calculator. The 20.875 still there. Multiply times 1.1, which is 110%. And we get the 22.9. Now, the 22.9, right, is the ampacity, the minimum ampacity, right? 22.96 amps. So that is the ampacity, right, of the conductor. But we need to size the wire, right? We need to size the wire. So let's see if we can remember, right, in unison, right? If we got this ampacity, what table are we going to use to size this wire? And everyone says table 310 15 B 16, right? We've been there a whole bunch of times, right? Let's go there one more time to finish this thing up. And remember that when you're talking about a motor, which is what this is, use the 75-degree column. Now, it'd be interesting if this thing states THHN and they're additionally getting tricky on you, but you would use the 75-degree column if you're talking about a motor. And if they tell you THHN or something using the third column, don't go for the bait. That would be incorrect. Okay, so let's go ahead and back up there to that particular table. Table 310.15 B16, and let's finish this thing up. Okay, I should be close here. Okay, computer's not cooperating with me here. Okay, there we are. Now we're getting close. Because there's ambient temperatures. That's the wrong table. This is the right table right here. Now, remembering to use 75 degrees Celsius, and we came up with 22.9. I don't see 22.9, right? I don't see 22.9, but I see 25, right? So once again, using the 75 degrees C column, got to make sure we're on the right column here. Down to 75 degrees C to 22. There's no 22, so you got to go to 25. Follow it on over to a number 12 AUG. Number 12 AUG conductor. So inner notes. Let's finish this thing up. We need number 12 AUG. I'll put a box around that because that is the answer to that question. Okay, so taking a look at the question one more time, we got 12 AUG inner notes as the correct answer. There it is, right? What are the branch circuit conductors required for a single motor? In this case, it turned out to be multiple choice number 1, 12 AUG. I appreciate your time. Thank you.